How'd you do?
AgMechanics deals with electrical motors, small engines, electricity, and so many more exciting things. Everyone should study AgMechanics because it teaches you things that you may need to know in your future, and it's freaking fun. So, here we go.
2, 1.
To determine watts, you multiply volts and amps. A measure of the amount of energy or work that can be done by amps and volts is called the watts. Volts are the measure of electrical pressure, and amperage is the measure of the rate of flow of electricity in a conductor.
Okay, so this is a circuit diagram. Basically, you have your power source, you have your outlet, your light switch, and your light. So to hook this up, you're only going to be using 2 wires. Well, 2 different color wires. You're going to be using a black one, which is your hot, and then a white one, which is your neutral. What you're going to do is you're going to start from here, go over to this light switch, well, to the outlet, and then you go from here, yeah, you're going to go from here, go all the way over to your light switch, and then take your black wire and you're going to go over to your light. Now, the white wire never touches your light switch. So you're going to take it from here, go all the way back to your outlet, right there. Take it from up here, and go back to your power source. And that's a circuit diagram.
Okay, what Brandon just talked about was the wiring diagram of how to wire a switch into a light. And to explain that is my colleague.
First you're going to need Romex, which is this wiring, has all the wiring inside. This is 3G, it has an extra hot, which you don't need for this. This would be your power source coming into your switch. You would put your hot coming in to this, and then your hot coming out into the light. And then your white passes through the switch, and you wire those together, and that will go back to your power source. And then your switch will be grounded to the box. It has to be 8 inches of Romex outside the box, and then that will all tuck in there, and it will bolt onto that. And then
Nice and compact. Now, to do this job, you have to have certain tools, such as this little wire stripper. What you do is you take the wire stripper and you clamp onto the Romex and pull really, really hard, and it comes off. Then you have to have needle nose pliers. These also are wire cutters, but we use them to spin the little hooks on the wire so that you can screw it into the switch. Most important are the wire strippers. You have to strip the wire to hook it to the switch and to the light. These are an electrician's best friend. Then you have a screwdriver. Simple, yet very, very neat. You just unscrew these and screw them back in with this thing, and you have electricity. Electrical motors, nameplates, and parts. An electrical motor. Very, very handy. On an electrical motor, there's a capacitor. This helps the motor to start under a heavy load so that it can do more. There's the rotor. This thing right here, it looks kind of like a shaft. And there's the stator, which is inside of the housing, which is this right here. There's the air. I don't know if you can see that, but it's in between this and this rotor, and it keeps the motor cool so it does not burn up. Then there's the bearing, which are inside right on this thing, which let the stator spin inside of the rotor so it creates electricity and it doesn't gald it up or ruin it. And then there's the pulley, which you hook to whatever you need to move or make go.
Okay. The electrical motors have nameplates. This has all the information of the motor. We have the model number and the cat number, which has to do with the maker of the motor. We also have horsepower. This motor has 1 horsepower. rotations per minute, which is how many times the motor spins in a minute. We have the hertz. We also have the pH. The phase. This is a one phase. We have the volts and amps of the motor, and we also have the insulation class. This is insulation class A. Here we have the service factor. We have the code number, and we have the ambience number. Frame numbers here. We also have this has sleeve bearings in it, and the time rating. This is a continuous load motor, meaning it can work continuously. And the ambience number is shows how hot the motor can work at. This can work at 40 degrees Celsius.
Tool reconditioning. Tap and die, drill bit sharpening, and cold chisel sharpening.
For drill bit sharpening, your drill bits get wore out and dull, and it costs a lot of money to buy new ones, and it's just a lot easier to learn how to sharpen new ones, or your old ones. So what you do is you turn your grinding wheel on, and you always have the face shield down, and you just going to want to round it. This is your guide. You want this angle, and this one is definitely off. So you start. What you want to do is pretty much just get your angles set first, and then what you want to do is get the backside as smooth as possible and just a round edge where it'll be the sharpest. What you want is to get the angle as close as possible.
When you sharpen a cold chisel, you have to have a tool gauge. The first thing you do when you sharpen one of these is make sure that the cutting edge is flat, and to do that you just put it in the grinder and level it off, and after that you have on tool gauges you have a 30 degree angle, and that's the angle that you want your cutting edge to be set at. So I need to level off the nose first. And then it's 30 degrees and it's perfect.
Tap and die, the most essential thing to a mechanic who strips out bolts. First thing when you're doing a tap and die set is to have a good pair of safety glasses to protect your eyes. What you are trying to accomplish here is to make a bolt here fit into a nut here. So what you first want to do is make your nut. You stick it securely into a vise, and you take your tab and you secure it into your little wrench. And what you want to do is you don't want to put oil in it until you get the thread started. So you hold it level and you spin it until you think it is started. So there it started. You go back about a quarter of a turn, and then you go about half a turn, applying oil when needed. And this is Rapid-Tap oil. Very, very good stuff. So you go half a turn, come back, you keep going, come back, going, come back. Then pretty soon you will have made your nut. So then it's time for your bolt. Now, what you would do to start off the bolt is see how this edge is ground off a little bit? Right there. You ground that off so that your die will start on this very, very good. So you secure it in the vice versa, making sure that it's straight up and down. And once again, you do not want to put oil on it until you get it firmly started. So you start, and you get it started, then you go back a quarter of a turn, then go half a turn, then go back, applying the rapid tap oil when needed. Then you go, and here we made a bolt that had an inch of threads, which would be 16. 16 means there's 16 threads per inch. So if this is an inch long, there should be 16 threads here. So once you've done that, you now have a bolt and nut.
Fencing. The types of fencing is woven, wooden, chain, electric, and barbed wire.
How to build a woven wire fence. First, you need to set up the supports. Stabilize them with concrete or packed dirt. Second, once the supports are in place, put in the T-posts equally apart down in the designated area. Now, roll the woven wire fencing down. Now you roll the woven wire fencing down. The fence, first connect the fence to the supports. Then tighten the fencing and connect to the T-posts. Once the fence has been tightened and connected to the T-posts, run 2 rows of barbed wire on the top into the you just made the woven wire fence.
I have this mower and it's like working this morning. I have this mower and it stopped working this morning, so I was wondering if I could get a refund. Yeah. I was trying to win some big bucks, and so I was racing it this morning, and it just stopped running.
Our server policy is if it's been under abuse that we can refund it. But what I can do is I can send you a cheaper mower that's reliable.
Okay, I guess that'll work.
Anything else I can help you with?
No, thank you. Hi, I'm Tessa Knight, and I'm from Home Depot, and I would like to invite you to this luncheon Saturday at our store. We have a new line of hammers that they're very powerful, and they're black, so your hands won't get cold. So I was wondering if you'd be able to make it.
Can you tell me more about the hammer?
They're black, they keep your hands warm. They're magical, and they're very powerful. Everything. Thank you. We just saw an example of ag, customer relations, and prospecting, and now we're going to talk about the ad layout. In the corner, you should have a picture or something to draw their attention, and what your business is. And in the middle, you should talk about what your sale is or what's going on. And in the corner, your signature and your hours and where your store is located. A good ad layout should create interest in your product or service and connect with someone who needs your product or service.
Hi, I'm Cody.
I'm Brian. And today's topic is small engines.
We're going to start off by telling you about the basic small engine parts and the function of those parts. And also we're going to bring up troubleshooting.
This is the arbiter. It sends a spark to the spark plug. These are tappets, and they control the valves. This is the oil slump. It covers the bottom of the block and holds crankshaft and the camshaft. This is the camshaft, and it controls timing, and when you put it back in here, you have to make sure that the dot is lined up with the notch.
This is the oil slinger. It lubricates all inside the cylinder and piston and everything. We got the spark plug, causes fire to the engine, and the muffler releases exhaust, and we got the head which holds the spark plug.
We also have the head gasket, which seals off the block and doesn't let any air escape.
We got the piston and the cylinder, and let's see. Well, inside there we got the rod and the crankshaft. Crankshaft basically rotates, moving the piston up and down.
These are the valves. The one releases exhaust, and the other one lets fuel into the cylinder.
And here we got the flywheel, causes momentum and keeps the momentum going.
This is the carburetor.
Provides fuel to the engine and
Gas tank.
Gas tank. You know, kind of obvious enough. So, and troubleshooting is when you're trying to figure out why your engine won't fire. So the main points that you want to check is your spark plug, the gap between the armature and flywheel, which would be on here. So let's say the armature is hooked up, and you have to have a certain gap from the armature and the flywheel. And so, and also you want to check the carburetor to see if there's any dirt or corrosion inside it.
Surveying and rafter layouts. Okay, so this part is surveying. First, I'm going to show you guys how to read a rod. Now, it's not that complicated, but it's hard to read. Now, the red numbers are feet, and it's all measured in hundredths. Like, when you look through the transit, and you see probably this little part right here, hold on, that part, that would actually be 4 feet, 4.51, and this one would be 4.52, and so on and so forth until you reach up here, and then it changes to 6. And yes. Okay, can you take that, please? And can I have you stand over there by the prompt? Now, with surveying, what you want to do is you want to make sure that it's all level, and to do that, this little piece right here, the little bubble inside of it has to be directly under, well, in between the bigger 2 lines. And when you're surveying, because you want to make sure it's all level, you use these, which are called adjusters. And when you move it around, the bubble should not move. So when you're surveying, you want to look through this. And if it's a little foggy, you want to use one of these, and then it kind of clears it up for you. So when you look through it, like right now, it's pretty foggy. And, okay. So what I see is 4.92. And it's relative. Like if you know how to read it, it's pretty easy. So yeah, that's like the elevation of that part. So that's practically the beginning of surveying. This is rapid plans. Now it's pretty difficult, but if you know what you're doing, it's really easy. First, you want to get basically like your slope. So right here, I have the width of the house being 18 feet. And when you go directly up, it's half. So you can cut 18 in half, it's 9. So that's right there. And then this part is 3 feet high. So that's 3 feet. And to find this part right here, you want to use a squared plus b squared equals c squared. So, right now our a is 3. So 3 squared plus 9 squared equals c squared. So 3 squared equals 9. 9 plus 81 equals 90. And so you want to find the square root of 90. which is actually 9.4 feet. Now that you know that, you know this part, right up here. And you're gonna have a 1 foot overhang. So you wanna add 1 foot onto 9.4 feet, which is 10.4 feet. Now that you know that, we're gonna go over to the board, and I'm gonna show you how to do the measuring. And I'll do it from this side so you guys can see. Alright, so seeing how the slope is 3/8, you want to take this, and you want to find 3 and then 9. Hold on a second. I'll put it over here, and then line it up. So there's 3, and there's 9. Yes. Alright, and then you want to mark it. I use chalk because it's really easy to see than pencil. Okay. Now, as you can tell, my board isn't 10.4 feet. So what I'm going to do is I'm just going to go to the end, measure 1 foot from the end, and then mark it. And that is where your bird's mouth is going to be. Before you do the bird's mouth, you want to make sure that over here you have the same angle as the other. So you're going to do the same thing. You're going to find 3 and 9. Oops, I have it backwards. I have it backwards. So 3 and 9. Then you want to mark that. Now, to do the bird's mouth with a 2x4 piece of wood, it is always 2/3 inches. So you want to find the 2, and then you want to find the 3. Set them on the right marks, and then mark it. Now all you need to do is just cut it, and then that's your map.
Now you know everything that we learned in one semester of ag mechanics class. Hope you enjoyed it. We sure did. We went over electricity, determining watts, amps, and volts, drawing circuit diagrams, and wiring